The contamination from e-waste contributes to adverse health effects in Guiyu and its neighboring communities. People are exposed to hazardous substances through multiple routes, including water, air, soil, dust, and food. Toxicants such as mercury, cadmium, chromium, PBDEs, and PCBs present cumulative negative effects in neuropsychological functions such as cognition and behavior. Two populations whom are particularly vulnerable are pregnant women and children. Studies concluded in Guiyu report that the residents have a high incidence of skin damage, headaches, vertigo, nausea, and gastric ulcers. Because of the unique ways in which children interact with the environment, they are likely to receive bigger doses of toxicants relative to their size than adults. An exposure of contaminated food such as rice, combined with inhaling lead through house dust, puts children at high risk for neurotoxicity, leading to irreversible cognitive deficits in children and behavioral and motor skill dysfunction across their lifespan. Moreover, pregnant women are at risk of possible perturbations of fetus neurodevelopment. Breast milk from mothers at e-waste sites indicate elevated exposure to toxicants such as dioxin compared with milk from mothers at a reference site. This results in more spontaneous abortions, stillbirths, premature births, and reduced birth weights and lengths in Guiyu. Of the plethora of neurotoxicants from electronic waste, perhaps the most detrimental is lead. Elevated blood lead levels are described as those greater or equal to 10 micrograms per deciliter in children aged 6 and under. The blood lead levels in children of Guiyu range from 4.40 micrograms per deciliter to 32.67 micrograms per deciliter, with a mean of 15.3. These elevated blood lead levels are inversely associated with children's cognitive abilities and behavior. Lead undertakes calcium's role in the brain, including communication between neurons. When a neuron is activated, calcium enters the neuron and stimulates the release of neurotransmitters. Neurotransmitters carry the activation signal from this first neuron across a small gap to the next neuron, thus passing the signal. When lead is present, less calcium can enter the neuron, which sends a weaker signal to the following neuron. Lead can also cause spontaneous neurotransmitter release in non-activated neurons, which leads to inappropriate signals. Neurotransmitter signaling is especially important for learning and memory, and lead exposure impairs these processes.